So hello everybody, and today we will come to another video, and today we will talk a bit about large language models and basically Retrieval Augmented Generation, so which is generally known as RAG in the field. This is a bit a more practical tutorial. We will not go into the architectures in detail of large language models. We will go a bit into the architecture of the RAG. The stuff here is basically how can you on your machine get something like this running, how can we run large language models on our machines, how can we talk to our own documents, how can we make use of our own text. This is part of this Retrieval Augmented Generation story here. How can we basically, for instance, install something like ChatGPT on our machine, use a PDF for instance, and get the data into this large language model and have a talk about a special topic about data which is locally on our machine. The whole thing here is made so that this can run on your own machine, that this doesn't go into the cloud anywhere, which also has various security implications, and I hope you enjoy this. So basically, as I said, this is a tutorial on how to run LLMs and RAG locally. So what you will learn quickly, so we will talk a bit about the llama.cpp system, which allows you to run a large language model on your system. If I have basically here already more than 10-year-old machine with 16 gigs of memory, and it runs large language models rather fine if you use them in the right way. And also we will talk a bit about embeddings. What are embeddings? What is an embedding model? We need this for the RAG. We will go to this back later, and then also we will, of course, talk about how to use local documents together with this whole system, and how to do this in a safe way without sending our data or queries somewhere to OpenAI or wherever where we don't know where this data basically, in what kind of hands this data comes. So what is an LLM? You know that an LLM is a large language model like ChatGPT, something like this. We want to build a machinery like this, and we have basically what it does, it automatically generates text, and if you do this in a correct way, it looks like a conversation. Basically it's just completion, so you build a prompt and it kind of completes this prompt, and if this is a question, then most of the time the completion is an answer, let's say it like this. And for this video we will use a pre-trained model, so we will use llama 3.1, which is an open source model trained by Meta that you can install locally on your machine without any communication to the exterior afterwards. So this is basically the whole story. So how we will set it up? So we will have our local client that I basically have written, and that you can download from the web and install on your machine. What you need is of course a Unix machine in order to do this. This local client, it includes a local vector database. You can then use a local document and store this in the vector database in order to make use, basically to make a query to the LLM-server and augment this query with data that you have locally stored on your machine in order to get responses in accordance to this local document. Yeah. So let's imagine we have a company, this here is the final year report. I want to ask the LLM server something about this final year report. Of course, in the training set probably there's no data about this final year report, but anyways, so we will put this final year report into the local vector database. The LLM server then can access, basically according to your query, the documents that correspond to this query and give you an answer taking this data into account. This is what this is all about. And in order to make this running, we also need an embedding server. About that so far, how this all works out. The LLM server and the embedding server of course can run locally on your machine or on another machine within your network, and you can be completely disconnected from the internet in order to have this in a safe environment and not leak your final year report, for instance, here to the internet. So how does this look like further? So how will this work? So we have this local document, we have our local client, we feed this local document in our local client. Once this is fed into our local client, this local client will split this document into subdocuments. This is very important because, of course, the input to the LLM server is limited. You can't have a whole thesis, for instance, put into the prompt of the LLM server, and so we have to split this into subdocuments. So currently we split it into subdocuments here in this tutorial, which are 2000 characters long. They can of course be longer, it depends on your machine, on the large language model that you will use. Here we will show in this tutorial how to split this into subdocuments that are around 2000 characters wide. And we will then basically, when we make a query from the local client, invoke these subdocuments from the local vector database into the query. Okay. This all sounds maybe a bit weird to you right now, but what is this all about? So when the local client then basically has this subdocument, he basically takes these subdocuments, he sends them all to these embedding servers and generates an embedding for them, and stores these embeddings together with the document in the local vector database. Yeah? Okay, what does this mean? So what is an embedding and what does this mean? So basically an embedding is nothing else than I have here some text. In this case, the text is the mother search for children at the school, and the embedding server, we can send this to the embedding server, and the embedding server generally generates as a vector, and this vector is varying on the embedding longer, rather normally at around 1000 entries long. It can also be longer or shorter, and this embedding vector, normally this is trained, this is a model, this is a machine learning model, which should capture with these values that we have here the semantics of this text. Yeah? So it should kind of encode what is the content of this text inside these values. Yeah? Of course, this is not perfect, this is also limited. Yeah, you can imagine that the size of this embedding here is fixed. If you take a very large document, this embedding might have no meaning or lose some meaning of it. But this basically should work for our vector database. This is what this is all about. We have this second text here, for instance, and we see, okay, well, we get a new embedding with different values, and the embedding model makes this happen. And then once we have this, we can basically store this as an index, if you want to, for this text, and we can store it as next to the text and kind of then find close embeddings to a query in order to find the right documents which we want to invoke when we pose a question to the large language model. Yeah. Okay. As I said, we have this vector database. So the vector database, basically what she does is she takes these embeddings and basically stores them next to our text in order to make them retrievable by an embedding. Yeah. How does this work like then? So we have our embeddings in the vector database, and then of course further in the end what you want to do. So we have the document in the vector database, we have little subdocuments with embeddings in this local vector database. And what we want is we want to retrieve these subdocuments based on a query that we make in our local client. Okay? So we use our client, we type a question, the question goes to the LLM server, at the same time the question goes to the embedding server. It generates an embedding for these questions. This embedding is used not to store in the local vector database, but in order to retrieve a document in the local vector database then, because it's the query, the question that we have asked to the LLM server. And the local vector database will send the appropriate documents that we have encoded before to the LLM server in order to augment. This is why this is called RAG. Yeah. In order to augment the query that we made. So in order to get a better answer, because we have a local document that kind of contains the answer or should contain part of the answer that we want to have. And then well, the LLM server in the final stage, it sends back his response to the local client, the answer to the question, if you want to. Yeah. So how does this work? How do we retrieve the data in the vector database? So we have a query. So the query, for instance, what I might ask is our LLM is did the mother search her children, or has the mother searched her children at the school? I'm sorry for the grammar mistakes, but I guess everybody gets it. And then basically here we see that the answer basically, or what is found in the database, is the mother searched the children at the kindergarten, which might be a document that is found in the database. And it will send this document to the LLM, and the LLM will then from this document and our question construct an answer using its neural network. Yeah, this is basically how it works. And in order to find similar documents, well, this is very easy. We use basically the cosine similarity. So what does this look like? So we have embedding 1, the question, and then we search. Here we have a lot of embeddings basically in the database, which look like this, and we look for which embedding is the most similar to the question. And we cannot only send 1, but we can send maybe 5, 6, 10 answers to the LLM as a context. So we take the 10 closest, for instance, the 10 closest responses from the vector database and send it to the LLM, and then we say, okay, this is the question, this is the context to the question, please build an answer out of it. Okay, that's how this works. And we use this cosine similarity in order to find close answers, close documents in the vector database. As I said, we have a large document, we have to split it into very short documents. So in our case, we will do this here for the sake of simplicity to 2,000 characters. And then, of course, we find these 2,000 character long phrases that we can then send to the LLM in order to get appropriate answers. Okay? Okay, so far so good. Let's get practical. So we have basically, how do we do this all in practice? What does this all look like in practice? That's the big question here. So first of all, we need what we have here. We need an LLM server, and we need an embedding server. And in order to get this running, we can use basically a llama.cpp. So llama.cpp is a module which allows you to do this. You can download this here. I will show this to you here. I prepared this here. You can download this here on GitHub on this website here. Where you can basically have the this server here. You just basically clone this repository. You already know from my previous videos how to clone a repository, so you just do git clone this repository. I won't go into the details here. We already did this. If I go here, I did this on my other machine, so I have to connect to my other machine. And we're here on my other machine, and I have here this llama.cpp folder where I basically have this server already downloaded. Yeah. So git clone, you know how this works, how you get here. In order to build this, you need, if you're on a Debian based system, the build essential. I guess I already covered this also in my other videos. So basically what you would do is get install build essential, and you need some libraries. You need cmake and cmake. What I suggest you is that you use cmake curses GUI, because then you can basically install this with a GUI. Yeah, so it just looks like this. You can do like cmake, ccmake. This is the curses GUI dot, and then you basically configure this here, and you don't need to configure the prefix and all of this. Normally this is auto configured. You do whatever you imagine. If you don't know what to do, just skip this and do basically configure and then you can, after configure, you can type generate with G, and then you can basically do make, and it compiles the whole system. So the next step would be to type make J with the number of cores that you have on your machine in order to make this faster. And then you have everything installed. That's basically how it works. Yeah, it's as easy as that. Okay, so right now we have our llama.cpp server, and we need this server basically in order to run two things. So in order to run the embedding model, and in order to run the large language model. So I downloaded here several models. The large language model that we will use here is basically this Meta Llama 3.1 model. It's an 8 billion model, and it's quantized so that it fits into the memory of the machine. The memory of the machine here has 16 gigabytes of memory. 6-bit quantization is rather good actually, so it works rather well. You will see this, and we use the embedding model. So the embedding model, or again a machine learning model that you can run with this type of server. We use the nomic embed text model, and basically the file extension for models that this llama.cpp uses is the gguf file extension. You can convert models yourself from Hugging Face into this gguf extension. You can also just download the gguf files, and if you trust them and run them, this is basically what I did here in this case. So just to see where you get this from, so if you go here to Hugging Face, internet is a bit slow here. And you type here, you see you have here basically llama 3.1. If I do this like this, and then you type gguf, we see this is probably the model that I downloaded. So I can click on here, and I go get into the website of this model, and I can then say, okay, I see I have this gguf file format that I can download here, so I can directly go into files and download the file from here. I use the 6-bit one, so you see that you have multiple files here, and you have this here is the Q6K. If you look at it, this is the one that I downloaded. You can download this file from here and work with that. So this is basically the model that we have used. And the second thing was this nomic embed model, so let's search for these ones. And you see this is basically the model that we have used here, and it's the same story. You just download the gguf file. You have here some files, and you can download here this embedding model in order to run this. Yeah, very easy to get this all running. Once you have these files, you need to run your server, and basically you're already done if you just run the server. So the story is like, if you just want to have a simple conversation, you could do like if you do this like me and you don't basically do make install, you can just from this folder you have like a bin directory inside, and there's a server file, and if you see this server here basically has all kinds of options, and we will run this. So we can say -m is the model that you want, and then you can say okay, the file that you have downloaded, that's it, and that's everything you have to do. So also the context size that you have to specify in order not to use too much memory on this machine. I will go with a context size, as this model has up to 128K of context. This is basically how many tokens you can basically put as an input to the machinery at once. And so I go here to 25,000 tokens context size, yeah, something like this. And I run this here, and then basically what else I have to do is I have to tell okay host 0.0.0 so that it's on a public IP address, because otherwise this would only run on the local host, and I couldn't access this machine as this is not a local machine. Otherwise you can run this, of course, also on your local machine, but the little laptop where I record this video is not powerful enough, so this is why I run this on the machine which is next to me, which runs this server here. So if I run this, what went wrong here? I guess it's -- host, and basically it's charging this kind of model here. And in theory, once this model is basically run into memory, we can just use a browser, go to the website of this model, and run it from there. This is the first thing. While this runs, we will do the same thing and run basically the embedding model, because we also will need the embedding model for our RAG system. We do this while this loads here, so that it can load the two in parallel. So as you see, I'm connecting to my remote machine again. I go into this drive where I basically have installed all this, and we do here again llama.cpp bin server, and when we have the embedding model, basically we can say, okay, we have this nomic embed gguf file, and we basically go here and we say, okay, embedding, I guess it's like this. I will just double check with -h. Yes, it's embedding. Okay, so we just need to do this embedding host again, 0.0.0, and we also need a port, so that basically the embedding model isn't running on the same port as the machine learning, as the large language model, and we do this on 8081. Okay, so far so good. We have our two ports, we have our two models running, we have the embedding model running, we have the large language model running, and the large language model was already loaded. We also see basically that the embedding model is loaded, so both systems are ready to go, and basically we can interact with them. So if you just want to run your local model, you can go into your browser and you can then say, okay, the machine that this runs on, if you do this on your local machine, you could type localhost, but this here is on the machine next to me, so I will do this like this. And you get a user interface like this, and you can basically ask your questions here, and the model will give you some answers. So, how are you? And as I said, the machine is more than 10 years old, so the answer will take a bit of time, but it will come. And you see basically it generates tokens, so it generates text. Okay, it looks a bit strange, but that's the way it is, and this is the normal UI. If it doesn't use here any rag or anything, this is basically the UI that comes with this server tool, but we can also use this with the tool that I provide you, so that you can use this with rag functionality. Okay, so we close this here, and we have our own system here that you can download here on GitHub. So you can go here, this is basically the URL. So here you have basically this tool, how to interact with the system and how to interact with the system in a RAG fashion. As I said, we use here the cosine similarity, we can use our own documents, and we can basically run this whole story here. Okay, that's basically it. So we have here this command line RAG tool that we need to download and build, and in order to download and build this, well, basically you get here all the instructions. You also need basically just build essential. It requires libjson, GNU readline. So let's do all this so that you see how you can get started and running with this. So I already did git clone, and basically I could do something like this, but I already did this, so I have this folder already here. and the folder is already here, and if I type basically make in here, that's all you need to do. So if you don't have all the libraries, and if you're on a Debian system, what most of the people are today, otherwise you download the libraries depending on your distribution. You could basically just do, why didn't it copy and paste the way I want it? You could just do basically this and install all the dependencies in order to get this running. If you have all the dependencies, you just type basically make, and it builds the whole system that you need here in order to interact and have our RAG system running. So we built here our RAG tool that I showed you, that you can basically get from GitHub. And we have this here, and we see that we have several tools here. And the first thing, of course, that we need is, as I said in this story here, is, well, we need to get our local document that we want to have and basically split it into subdocuments, send it to the embedding server, and build this local vector database. We build a local vector database from a document that we have, and for this document I will take an article that I've written here that we have on bioinformatics, which is MNH and tree tools, and we'll just download the PDF of this document here and show you how we can basically encode this into our system here, into how we can build a vector database from this local document. So we have here the PDF. We save this PDF to our drive. It's called ptab430, as we saw. We can close this here, and we have here in downloads ptab430. And of course, this only works with text, so we do PDF to text, and we take this ptab330 document, and we will get here text out of it. So if we have this here, we have our text document that we will use in order to fill our vector database. So we use this document and we will build a vector database from it. So how do we do this? Let's go back to our client rag. We have here bin, and in this bin basically we generated several binaries with our make command before, and we can use build vector database from server. As I said, we need this embedding server, so basically we take this text document, we put it into slices of 2000 characters each. These slices will be sent to the database, to this embedding server. We will get the embeddings back, and we will build a database from that. So what we need here for is, we need a file, a text file, as I said. We need the hostname, the port of our embedding server. We need the number of characters per slice, and the vector database that we want to write out. Very easy. So what we will do here is, we take our text document, which was stored in downloads ptab330 text, and we say, okay, the host name in this case is the machine next to me. Otherwise, if you run this locally, as I said, run this on your local machine. We said that the port of the embedding server is 8081. We need the number of characters per slice, as I said, we do around 2000, and the vector database will restore it next to this one here, and we say this is the vector database of our document, where basically we have these slices of 2000 texts. Each text gets a embedding vector, and then we build this vector database. That's basically it. And if you run this, we see we get here some activity on the console while this vector database is running. It basically sends these documents over and gets the embeddings back. And there was an input which was too large. This is strange. This should basically work. Let's get it a bit down here. Okay, let's not go to... Let's do it a bit less. Let's just take 1500 characters. Not sure how this happened, that we all of a sudden have one which is too long. And we see it worked. So probably we should have increased the context size before, but here, okay, let's stay with 1500 characters per phrase, and then we can just basically recover more phrases during the embedding stages. So if you get this error like here, input is too large, so you can basically increase the physical page size, or you can basically just say, okay, I decrease here my input length. Normally with 2000 characters it works, in this case it didn't, but with 1500 we were fine. That's the way how it works. Yeah, okay. So we have our vector database. As we have our vector database, we can now basically run a query on this and use our reg tool. So the story is, how does this work? We have here right now our tool, which is called reg with VDB cost client. So we also have, of course, here this embedding from server client just gives you an embedding for some text that you send. The reg conversation basically works without a vector database. We said we want to work with this vector database in order to augment our text with this PDF that I've sent you here right now. And how does this work? So we need basically both servers, because we also need to send the query to the embedding server in order to query the vector database I've explained to you before. So how do we do this? So we run basically our bin reg with vector database cost client. We say the LLM-server port. The LLM-server is the machine next to me. The LLM-server port by default is 88. How many tokens I want to answer, so how long do I allow the answer to be? I'll say infinite, so basically when the LLM says, okay, its answer has ended, it sends like an end token. So with -1 it waits until this end token. It can be very long. I hope it will not too long, but we just ask one question in order to see how this works. Then we need the vector database that we have generated. So this is downloads ptab 3c vector database. We need the embedding server, so the embedding server epr.local 8081, and that's basically it. And then we get a prompt. So this prompt basically is our human input. You type, and then you can have a conversation about the text that we have stored in this vector database ptab 430 VDB. So right now you have learned basically how you can converse with a local document that we've downloaded, that we've converted to text, that we converted into a vector database in order to work with this system. So how do I do this? So what was basically the contents of this document? It was managing tree tools. So I will say, okay, give me a summary about the usage of managing tree tools. I just see that I made a mistake because I forgot to give here, so I don't know how this works, but basically we need to have here how many queries we want to have back. So we say 5 queries, as we have 1500. So we do 5 documents, 5 times 1500 characters, as we have changed it here. To get back from the database, this should work right now. There's something wrong. Okay, this is the vector database and the number comes afterwards, I'm sorry. So 5 queries to return. And so I say here my question managing tree tools. Usage and its general usage. Brief overview. Okay, so when you're finished here, when you have entered your question, basically you can have multi-line input here. This was programmed so that you can copy-paste text here. And in order for this whole thing to work, so once you have entered your text, you just finish with Ctrl-D. So I type Ctrl-D right now, and as you have seen, something came up here, so it sent it to both servers. So we need the embedding and get basically the embedding back in order to create the vector database. The vector database, it will basically fetch the documents that are in accordance with my question that we have. So 5 documents which are the most similar to my question from my from the text document that we process, and then we will get an answer. So it will take a while, as the machine is, as I said, more than 10 years old, that runs this LLM. But soon it will produce tokens. It also takes a bit longer. As we said, we take these 5 times 1,500 characters long text parts, and it will basically generate a very large input to the LLM. So the prompt is very large in this reg store here. But very soon we will generate an output. Hopefully. The machine is running. Yeah, I hope you hear the fans maybe as it does its best in order to answer the question. And of course, just to notice, well, it couldn't give an answer because, I mean, I'm not sure if it's part in the training set, but probably the LLM might never have heard about managing tree tools before, but as we have it in a local document, and we can basically put this local document, data from this local document, into the reg, into the prompt, the system knows about it and can give answers accordingly. Yeah. Sometimes you can also program this so that in theory that basically that you only want to have answers which are encoding to the documents provided by the reg, so that you this way you can kind of build a safe LLM tools which only work on a subset of information that you give it. Yeah. This is rather slow today. We will check it out. Let's go over to this machine. Let's see what takes us so long, if we are running or not. So as you see, the CPU is at full speed. It's processing all these inputs. And we get the answer. which is actually what you find in the document. The answer comes back from the LLM according to the document that we have sent to it. And of course, all these things, you find it in the document that we have encoded here in this PDF document. This looks pretty right to me, as I'm the author of this document. So as I said, that this way you can talk to local documents on your system. You can use these tools also just for a standard conversation, so you get this human machine story here. Could like now say like something like tell me more, and then it would continue. We will stop it here. I guess this is enough for this video. I have shown you basically how you can build a RAG, how you can do it practically, how you can use my tools in order to get your own RAG running, in order to talk to your own PDF files locally on your machine. This is basically what this is all about. I hope you have fun with this video. Thank you so much. Thank you so much for watching it.